Yeah, welcome back. Today we are going to discuss about a very important topic for your external point of view. The name is Bicmos inverter. Here I am going to talk about four different configurations or structures of Bicmos inverters. In that you can very easily observe that which structure is good for us. Is it clear? Now if you observe that here you can clearly observe that in the front section you are having a CMOS, and in the at the load section you are having a bipolar. Is it clear? Therefore you can clearly say that BiCMOS is a combination of two technologies. One is what? CMOS technology, another one is what? Bipolar technology. Now you can observe the operation of it very clearly. Okay, now you can observe here. Let us observe very carefully one important point here. When Vn is equals to 0, what is happening? Now you can observe I am giving the names of the transistor as T1, T2, T3 and T4, where T3 and T4 are the T3 and T4 are the NMOS and PMOS transistors respectively, and T1, T2 are the bipolar transistors which are NPN transistors. Is it clear, all of you? Now you can observe very carefully. When Vn is equals to 0, what is happening? When Vn is equals to 0, T4 will be turns on, T3 will be turns off. Therefore, this VDD is going to be hit to the base terminal of T2, because T2 is receiving the current through the PMOS transistor. Therefore, there is a path from VDD to Vout. Is it clear? Then what is happening here? In the NMOS transistor, it is in off condition. Therefore, no current is passing to the base terminal of T1. Therefore, we do not have any path from Vout to VSS. Therefore, it is very clear for us when Vin is equals to 0. When Vin is equals to 0, there is a path like this. Is it clear? And you can observe that then there is an output like this. Therefore Vout is equals to what? 1. Similarly, you can observe very carefully when Vin is equals to 1, what is happening? When Vin is equals to 1, T4 transistor will be turns off, T3 transistor will be turns on. Is it clear? Now there is a path like this. Is it clear? It will hit the transistor T1. Is it understood? Now you can observe that this transistor T1 is going to be turns on, then Vout is going to be have a path to discharge a load capacitor. In this manner, there is a 0 at the output. That is very clear for you. When Vin is equals to 0, you are having Vout as 1. When Vin is equals to 1, you are having Vout as 0. Is it understood? Okay, this is operation of Bicmos inverter of the structure number 1. But you can observe very carefully what is the drawback present in this structure. Now you can observe very carefully. Now when Vn is equals to 0, what is happening? You can tell, yeah, absolutely, there is a path like this. Okay, is it understood? Then there is a path from VDD to Vout. Therefore Vout is equals to 1. Is it understood? Now if you observe that when Vn is equals to 1, what is happening here? You can clearly observe when Vn is equals to 1, this T4 will be in off condition, this T3 will be in on condition. There is a path like this, and the Vout is having a path like this. Is it understood? Now observe very important point here. Even though the T4 is in off condition, the base terminal of T2 is having a current. It doesn't have a discharge path. Is it clear? It doesn't have a discharge path. Is it clear? Therefore there is a leakage current. Therefore there is a leakage current. I hope that are you clear. That means it is still in what condition? On condition. Actually it should be in which condition? Off condition, because there is no discharge path to the base terminal of T2. It is still in on condition. Therefore, is it clear? If you observe that the output never reaching to 0. I hope that are you clear. And one more important drawback is, you can observe very clearly, when Vn is equals to 1, what is happening? See, then if you observe that there is a path like this from VDD to what is that? VSS, which leads to what? A static current flow. Is it clear, all of you? Therefore these are the two major drawbacks present in this structure. For the first structure is what? Leakage current, more power consumption. Leakage current. Why there is a leakage current? Absolutely, due to what? Due to no discharge path. No discharge path. For whom? Absolutely, for base terminal of transistors. Is it clear? Similarly, when Vn is equals to 0, we do not have a discharge path for this transistor. When Vn is equals to 1 we do not have a discharge path for this transistor. I hope that are you clear. And one more important point is what? Yeah, absolutely, there is a static current flow from VDD to VSS when Vin is equals to 1 condition. These are the two major drawbacks we are going to talk about in this structure. If you observe that what is the next structure we are having, if you observe very carefully, this is the structure number 2 we are having. You can observe very carefully, this is a structure number 2. In this structure, if you observe that, okay, when Vin is equals to 0, you can clearly observe that what is happening. Can anybody try to tell? Absolutely, when Vin is equals to 0, okay, there is a path like this. This transistor will be turns on, this transistor will be turns off, and it will hit the bipolar transistor T2, and once again you can observe that the Vout is going to be charged to VDD. Is it clear? And if you observe very important point here, when Vin is equals to 1, now you can talk about when Vin is equals to 1, then this transistor will be in off condition, this transistor will be in on condition, then this output is going to be hit to the base terminal of T1, then there is a discharge path like this. Is it understood? Okay, now you can observe that there is no static current flow from VDD to VSS, because of MOSFET. I hope that are you clear. But what is the drawback present here? Can anybody try to tell? Yeah, absolutely. The drawback is what? There is no discharge path for the base terminal of bipolar transistors. We do not have any discharge path. Therefore, because of this, we do not have any discharge path. There is a chance of what? Static current flow from VDD to VSS. I hope that are you clear. To overcome this drawback, some other structure we are going to move. You can observe very clearly. Okay, some other structure. Yeah, now this is one structure. You can observe very carefully. Now if you observe that in this structure what is happening, observe very carefully. When Vin is equals to 0, as usual, this transistor will be turns on, this transistor will be turns off. Then there is a path like this. Okay, it will hit the bipolar junction transistor, and there is a path from VDD to Vout. Therefore, the capacitor is going to be charged. And when Vin is equals to 1, what is happening? You can observe very carefully. When Vin is equals to 1, this transistor will be in off condition, this transistor will be in on condition. Then you can observe that the Vout is going to be passed like this, and it will be hit the bipolar junction transistor T1. Is it clear? Then there is a path from Vout to VSS to discharge the load capacitance. Is it clear? But if you observe that whether we are having a discharge path, okay, now you can observe very clearly whether we are having a discharge path or not. Now you can observe when Vin is equals to 0, okay, this is the path you are having from VDD to this transistor, and from when Vin is equals to 1, you can observe that this is the path we are having, okay, this is the path we are having, okay. But don't forget that if you observe that very clearly, you may have a discharge path like this. See here, there is a discharge path when Vin is equals to from 0 to 1, it will discharge like this. Is it clear? And similarly, when Vin is equals to 0 from 1, okay, 0 from 1, this is having a discharge path in this fashion. Okay, this is having a discharge path in this fashion. I hope that are you clear. Therefore, it is very clear that in this structure we do not have any static current flow. Okay, we do not have any static current flow. Okay, we do not have any static current flow. And very important point is, okay, we are having a path for discharge. I hope that are you clear. Of base terminals. I hope that are you clear, all of you. But can anybody try to guess what is the drawback present in this structure? Absolutely, that is a drawback. What is a drawback? Even small values of resistors will occupy more fabrication area. Is it clear? While fabricating, okay, a small values of resistor, it will occupy more area. I hope that are you clear. This is a major drawback. Therefore, the final structure of Bicmos inverter is given as, you can observe that. Okay, this is a final structure of Bicmos inverter. You can observe very carefully here. Okay, now you can observe very clearly as usual the process. First of all, when Vin is equals to 0, this will be in on condition, and this will be in off condition. Then there is a path from VDD to this bipolar transistor, okay, through T4 transistor, and the load capacitor is going to be charged to VDD. I hope that are you clear? The load capacitor will charge, okay, from to VDD. And one more important point, when Vin is equals to 1, what is happening? Observe very carefully. Okay, when Vin is equals to 1, you can observe very carefully. This will be in off condition, and this transistor will be in on condition. Then you can observe very carefully here, because these two transistors will be in on condition. Then this is a path like this, and it will hit the, okay, now you can observe, once again I will draw the path. You can observe there is a path like this, and it will hit the bipolar transistor. This will be non condition, and the load capacitor is going to be discharged. In the same manner, when Vin is equals to 0, you can obtain 1. When Vin is equals to 1, you can obtain 0. Is it understood? But what about the discharge path? If you observe the discharge path very carefully, now see, when Vin is equals to 0 initially, this will be in on condition. Is it clear? There is a path like this. I hope that are you clear. But don't forget, similarly, you are having a path here. Okay, this is going to be turns on similarly. Is it clear? Okay, now you can observe that when Vin is equals to 0, okay, the load capacitor is going to be charged to VDD. Then you can say the V out is equals to 1. Now similarly, when Vin is equals to 1, you can observe very carefully. This transistor will be turns on, and this transistor will be turns on. Is it understood? Okay, this transistor will be turns off. Is it understood? This transistor will be turns off. Are you clear? Now you should provide a path. Now you can observe that when Vin is equals to 1 from 0, this transistor is turns off, but there is a current from in the base terminal of T2, but it is in on condition. Therefore, it will act as a discharge path. Is it clear? To the transistor T2. Is it understood? Okay. Now you can observe that from when Vin is equals to 0 from 1, when Vin is equals to 0 from 1, you can observe very carefully. When Vin is equals to 0 from 1, okay, now you can observe carefully. It will be in on condition. Now you can say that it is in, there is a path like this, and there is a path like this also. Is it understood? Then you can observe very carefully. It will be act as a discharge path, okay, to the base terminal of T1. Is it understood, all of you? In this manner, it is very clear for us that this structure is very easy, and this is a optimum structure of BiCMOS inverter. Okay, why? Because why it is optimum? Absolutely, there is no static current flow at all. Okay, there is no static current flow at all on whatever may be the basis. There is no static current flow. I hope that are you clear. And one more important thing is what? There is no static current flow. And one more important thing, you can observe that, okay, discharge path is available. Discharge path for, okay, both the transistors T1 and T2 is available. Is it clear? And no static current flow. No static current flow. Is it clear, all of you? No static current flow. Is it understood? Absolutely. And a very important thing is fabrication. We are not using any resistors. Okay, less fabrication area also. And what is the drawback if somebody asks? Absolutely. What is that? More number of transistors are required. More number of transistors are required. I hope that are you clear, all of you. That's it, guys. This is about today's class. And if you are having any doubts in the unit number 1, you can ask. Is it clear? I am sure that I am going to complete this unit number 1 section. If you are having any doubts in this section, please comment if you want any extra topic. In the next class, we will see some problems regarding to the unit number 1. Is it okay? Thank you very much. Have a nice day.